All right, greetings everyone. Welcome to the first part of the video for section 8.6, our final section for this class in this chapter. And I know before you start crying, don't worry, we still got a little bit of class left. So this is not the total end yet. All right, so in this section, we'll be talking about something called parametric equations. And I'll talk about the definition here and then talk about them a little bit more generally. So a system of parametric equations is a pair of functions, x of t and y of t, in which the x and y coordinates are the outputs of the function, represented in terms of a third input parameter t. So basically the idea is if we are working in Cartesian coordinates in our general paradigm of using x's and y's, the idea is that our x and y coordinates at a particular point are given as a function of a third variable that we usually use as t. So an example of a set of parametric equations might be something like x is given by the function 3t minus 1, and y is given by the function cubed root of t plus 7. Okay. And so as you can see, we could choose values for t, plug them in simultaneously into each of these equations and find corresponding values of x and y, and then plot points from there. Now, as I've mentioned throughout this quarter, we don't necessarily have to be working with x's, y's, and t's. In fact, our parameter, so that third variable that the first two are a function of, doesn't necessarily have to be t. In fact, we'll look at an example in a second of where it's something else. But also, x and y here don't have to be the variables we are working with. We could be working with v's and t's, r's and q's, anything like that. But the idea is that they are given, each of those variables there is given as a function of a third variable, which we think of as a parameter. Also, to use some function notation here, since each of these is a function of the variable t, as they do there in the box, I could write this as x of t, meaning x is a function of t, and y of t, meaning y is a function of t. Okay, so let's look at an example of this in terms of something we've already looked at. So over here on the right, I have a graph of a circle. And we're asked to give parametric equations for x and y that describe the curve on the graph to the right, which basically means we need to write some formula so that we have x equals something and y equals something in a way that will give us points along the outside of this circle. Well, if you think back to section 8.2 when we talked about polar coordinates, we already have a way to think about this, right? We know that we can write the formula for a circle using polar coordinates, where x is given by the form r cosine theta and y is given by the form r sine theta. In this case, since the radius of our circle looks to be 3, our two forms here would be x equals 3 times cosine of theta and y equals 3 times sine of theta. And from there, we could just choose values for theta, plug them in, and help us get points for x and y. And if we connected all those points, you would see that they would make this circle that we have here. Okay, so that's an example, again, of how we've already sort of seen parametric equations in this course. All right, so let's look at another example here that's a little bit more traditional with our x's and y's and our Cartesian coordinates. So here you see that the x, the variable x, is given by the function x of t equals t squared plus 1. And then we have y of t equals 2 plus t. And we're asked to sketch a graph of this. And we're going to start by doing this by hand, but then we'll see how this can be done using technology in the next video. So to do this, what I'm going to do is set up a table. And in this case, my table is going to have 3 columns. So I'm going to have a column for t, column for x, and a column for y. And what I'll do is choose values for t. So in this case, I'm going to start with 0, 1, 2, and 3. I'm going to plug those values in and see what I get for x and y each time. So I could start by, say, plugging in 0 for t up in each of these equations. And if I do this in this case, you can double check. It looks like for x, I would get 1, and for y, I would get 2. If I then plug in 1 for x, for t in each of these, for x, it looks like we would get, let's see, that would give us 5. And for y, that would give us 3. That was a lie. Sorry. For x, we would not get 5. We would get 2. If we plug in 2 for t, this where, and for x, we plug that in, we will get 5. For y, we'll get 4. And finally, if we plug in 3 for t in each of those equations, it looks like for x, we would get 10. And for y, we would get 5. And notice what this has given us now is a set of coordinate points, right? So we can think of each of these as being pairs that go together that we can use to plot points over here on our picture. So if I do that, so if I plotting the point 1, 2 right here, and I'm going to do that in this color. There's 1, 2, we have 2, 3, and then 5, 4. And then we have 10, 5 here. And if we connect those dots, it kind of looks like a little bit of a square root function that's maybe been shifted to the left or right. Okay, and so that's would give us a the graph of this parametric equation. Now, hopefully you could see that this could have some real world applications, right? If we imagine the coordinate axis here being a map, and maybe we're following the path of an object on that map, and let's say t in this case represented some unit of time, maybe like hours or minutes or seconds. Well, this first point right here came with t equals 0. So that might be like the starting point at 0 minutes or 0 hours or whatever. The second point could be, again, where it was after 1 second, 1 hour, 1 minute. The third point here could be where it was after 2 minutes, 2 seconds, 2 hours, and so on and so forth, right? So you could see how this might be a way to track movement. And again, we're seeing that the horizontal and vertical directions are functions of, in this case, time. But this doesn't mean we're restricted to values of t that are bigger than 0. So again, we don't know that in this case that t is a unit of time. So we could have also input -1 for t. And if we did that, let's see, for x, we would end up with 2. For y, we would end up with 1. And so we'd end up with another point over here. So 2, 1 like this. And actually, if we added some more points, we would see we would end up with this kind of this shape on the other side. And so you can see that the graph of this parametric equation then gives us kind of a parabola on its side sort of shape. Okay. So this also shows us how parametric equations, much like polar coordinates or polar equations, can help us to describe or graph shapes or objects that wouldn't necessarily be considered functions in the lens of our PreCalc 1 knowledge. All right, well, that's it for now. Thank you for watching.